Hi, my name is Marissa Hall, and today I'm going to be talking about combinatorics. All right, this here is my combinatorics PowerPoint. Let me get it started up. All right, combinatorics. So what is combinatorics? We're going to be talking about combinatorics today and probability theory. Combinatorics is a branch of counting. And probability theory. Probability theory is the branch of mathematics concerned with analysis of random phenomena. The central objects of probability theory are random variables, random processes, and events. The probability theory is a mathematical foundation for statistics. As a mathematical foundation for statistics, probability theory is essential to many human activities that involve quantitative analysis of large sets of data. Methods of probability theory are also applied to descriptions of complex systems given only. A little quote that I found is by Pierre-Simon Laplace, which says, probability theory is nothing but common sense reduced to calculation. In probability theory, you will always have a sample space. A sample space is the set of all possible outcomes in an experiment. An example, when two coins are tossed, the sample space will represent maybe a list, a table, or a tree diagram of the possibilities of what you will get. Some probability techniques. Many problems in probability theory can be solved by simply counting the number of different ways that a certain event occurs. Combinatorial methods play an important role in computing probabilities whenever equally likely outcomes can be identified, and sample space is finite. Now we give a review of some counting methods. A very basic technique that is frequently used in combinatorial problems is called the multiplication principle, which states that if a first operation can be performed in any of n1 ways, and a second operation can be performed in any of n2 ways, then both operations can be performed in n1 or n2 ways. Some of the common counting techniques that we'll be using in this unit are deal with permutations and combinations. Now, the main difference between these two is ordering, because with a permutation, you're going to be looking at the number of ways to arrange things. And with combinations, you're going to be looking at the number of ways to choose things. So the order doesn't matter with a combination. There are always more permutations than there will be combinations. One last thing I want to talk about is something interesting that you might be able to relate to with combinatorics and the probability theory is the pigeonhole principle. With the pigeonhole principle, we can see here that the pigeonhole principle states that if P items, in this case we're looking at pigeons, are put into H number of pigeonholes, that would be this equation PH, then at least one pigeonhole must contain more than one item. It's pretty simple there, as you can see the pigeons here and their pigeonholes, and we have more pigeons than pigeonholes, so there are two pigeons in this pigeonhole. All right, well, I hope I covered the basics of probability theory today and combinatorics. This has been Marissa Hall. Thank you.